Hey there, young explorers. Today we're diving into the exciting world of Newton's laws of motion. Picture this. You're playing with your favorite toy car. You give it a push and off it goes, but eventually it slows down and stops. Why is that? Or imagine you're trying to lift a heavy box. The harder you push, the faster it moves. But why? These are the types of questions Sir Isaac Newton asked himself, and his quest for answers led him to discover 3 fundamental laws that describe how objects move. These laws, known as Newton's laws of motion, are the invisible rules that govern everything from the tiniest particles to the largest planets. They're like the secret language of the universe, and today we're going to decode that language together. So buckle up, because we're about to embark on an exciting journey into the world of motion. Get ready to learn how objects move and why they do what they do. First up, Newton's first law of motion, also known as the law of inertia. For those of you who might be wondering what inertia is, it's simply an object's resistance to change in its state of motion. Or in layman's terms, it's an object's laziness to change what it's doing. Let's paint a picture here. Imagine an elephant on a cart. Quite a sight, isn't it? Now, if the cart is not moving, the elephant won't move either. It's content, just chilling, not going anywhere. That's inertia at rest. But what if the cart starts moving? The elephant, despite its incredible size and weight, will move along with the cart. It won't just magically stay in one place. It will continue moving until an external force, like friction or a wall, stops it. This is inertia in motion. You see, our friend the elephant doesn't like change. If it's at rest, it wants to stay at rest. If it's moving, it wants to keep moving. That's the essence of Newton's first law. An object at rest stays at rest, and an object in motion stays in motion, with the same speed and in the same direction, unless acted upon by an unbalanced force. But don't just take Newton's word for it. Look around you. A book on your shelf doesn't just fall off without a reason. It stays put until an external force, like a mischievous cat, knocks it over. Or when you're on a swing, you don't stop mid-air, you keep moving back and forth until friction slows you down. So, to wrap it up, Newton's first law, or the law of inertia, tells us that objects like to keep doing what they're doing. They resist change. Whether it's an elephant on a cart or a book on a shelf, if it's not moving, it won't move. If the cart's moving, the elephant will keep moving along with it. Next, it's time for Newton's second law of motion. This law is all about how force affects the speed or acceleration of an object. To put it simply, the more force you apply, the faster the object will move. But let's dig a little deeper, shall we? Think of a rocket launching into space. It starts off stationary on the ground, right? But when the engines fire up, it starts accelerating upwards, defying gravity. This is because of the immense force applied by the rocket's engines. The bigger the force, the faster the rocket accelerates. But there's another part to this law, which is mass. Mass is just a fancy term for how much stuff is in an object. You see, the more mass an object has, the more force it takes to move it. That's why it's easier to push a bicycle than a car. The car has more mass, so it needs more force to get it moving. So, to sum it all up, Newton's second law of motion tells us that the acceleration of an object is directly proportional to the force applied and inversely proportional to its mass. In other words, if you want to go faster, you have to push harder. But if there's more mass, you'll need to push even harder. Remember the rocket? It can blast off into space because the force from its engines is powerful enough to overcome its mass and the pull of Earth's gravity. That's Newton's second law in action. And that's not all. This law is at work in our everyday lives too. When you kick a soccer ball, you're applying force to it. The harder you kick, the faster the ball moves. When you're riding your bike, the harder you pedal, the faster you go. That's all thanks to Newton's second law of motion. So the next time you're playing a game of soccer, or just fooling around with your toys, remember this: push harder, go faster. And now, let's talk about Newton's third law of motion. This is the law that reminds us that for every action, there's an equal and opposite reaction. It's a bit like a dance. When one partner steps forward, the other steps back. Consider a seesaw. It's a perfect example of this law in action. When one side of the seesaw goes down, the other side goes up. This is because the force exerted downwards is met with an equal force pushing upwards. It's a constant give and take, a balance of forces. This law isn't just at play on the playground, it's also the principle that allows rockets to launch into space. The force of the gases pushing down propels the rocket up. So the next time you're on a seesaw, remember, it's not just a game. It's a demonstration of Newton's third law of motion. When one side goes down, the other goes up. So, there you have it. Newton's laws of motion in a nutshell. These aren't just some dusty old science facts. They're the key to understanding how the world around us works. From the toys you play with to the stars in the sky, everything follows these rules. Remember Newton's first law, the law of inertia? Things like to keep doing what they're doing, whether that's sitting still or moving along. And the second law tells us that the harder you push something, the faster it'll go. Finally, Newton's third law reminds us that every action has an equal and opposite reaction. But don't just take our word for it. Go out and see these laws in action for yourself. Play with your toys, observe nature, ask questions, and most importantly, keep learning. Like what you learned? Give us a thumbs up and don't forget to subscribe for more awesome adventures in science. Stay curious.